Hey everybody. So to begin this video, we should first just mention the fact that there are more than 100 different chemicals that are identified as neurotransmitters in the body. The ones we are going to most likely talk about in this course and the one you're going to see most often are going to be ACH, acetylcholine, serotonin, epinephrine, and norepinephrine. These are also known as adrenaline for epinephrine and then noradrenaline for norepinephrine. So there are also neuropeptides that can be seen as neurotransmitters at all. And they can also modify these neurotransmitters and how they work. So with that said, let's talk about synaptic transmission. Again, please use other videos to help you better understand what's going on here, because hearing me say these things or you just reading them, it's still difficult to paint a picture of what's going on. This is all stuff we've already discussed in previous lessons. However, it is just important to keep in mind that there's nothing wrong with seeing stuff over and over again to better understand it. So let's begin here. A cholinergic synapse. So there are different types of synapses we're going to talk about specifically in chapter 11. However, one that we should get to know is the cholinergic synapse. What does that mean? It is mediated by acetylcholine, right? How do you know that? Acetylcholine. It is cholinergic. So that's the way I try to remember it. So, very important. We're going to talk about acetylcholine here. So, the presynaptic neuron, remember this is the yellow section, is going to transmit an impulse down to the synaptic knob. Once it gets to the synaptic knob, it is going to impact the synaptic vesicles and therefore release acetylcholine into the cleft. What did I say? We're going to have the presynaptic knob is going to get stimulus from that axon. So here comes a stimulus. Bam. That stimulus is strong enough to tell the neuron to send this vesicle, the white bubble, to the exit point right here at the end of the postsynaptic or the presynaptic neuron. From here, the vesicle is going to release all the neurotransmitters, in this case, acetylcholine, because we said it's a cholinergic receptor, into the synapse. So now we have ACH, acetylcholine, in the synapse. From there, it will then bind to the receptors on the postsynaptic terminal, which is right here. Remember, presynaptic's yellow, postsynaptic's green. The postsynaptic neuron is going to take these acetylcholines, and these acetylcholines are going to bind to these gated channels, causing them to open up, and therefore sodium and potassium are going to start to cross into the membrane. So when they attach here, oh look, I know it's kind of hard to see here, but these little blue sections here are the sodium channels. There's also potassium channels. Now all the sodium and potassium are going to start to enter the postsynaptic neuron. This is going to generate a postsynaptic potential, or a PSP. So what does that mean? We're going to change the ion concentration. So we're going to change the amount, the voltage within that tissue, within that membrane. So if you remember back to action potentials, if you increase the action potential past a threshold, you will generate a new action potential. So if this signal is strong enough, this will open up the voltage-gated ion channels and causing the neuron to fire. So in other words, the presynaptic terminal or presynaptic neuron is going to send a signal down here to the vesicles. Right? A signal is just sent. These chemicals, the neurotransmitters, are going to be released and then bind to receptors. And if there's a big enough signal, they're going to open up the ion channels and create another voltage. And if that's strong enough, it'll send an additional current. So in other words, the goal is to send a signal so that we can send another signal. Right? It's similar to the same process over again. The difference is it is mediated, it is started by those acetylcholines. Please watch this video a couple times. Please feel free to watch other videos online. If it were me, I would probably watch a different video first so you can get the animations and then come back here. So with that said, this is one example of how a cholinergic receptor works.